everyone. In this section, we're going to move a little bit away from Six Sigma and look at the 8 disciplines, or 8D, problem-solving methodology. Today we want to explain the purpose of the 8 disciplines for team-oriented problem solving, understand the importance and the interactions of each of the disciplines, and use the 8D methodology for problem solving and for corrective and preventive action implementation. Now, just a brief recap. As we've seen in this series so far, the Six Sigma methodology is a data-driven approach to achieve business success. Now, how do we do this? We started by carefully understanding the customer needs, listening to the voice of the customer, and mapping value-added business processes. We were able to identify and measure relevant, or we call these critical to quality parameters, which allowed us to quantify the baseline performance. And from there, we could see where we wanted to go in order to improve our process. We established cause and effect relationships. We built hypotheses for improvement and used statistical analyses to verify these improvement ideas. And then finally, we established long-term sustainability through process control. Now, as we said in the first part of the series, business success means reducing the variation and centering our critical to quality parameters, leading to reduced costs, reduced defects, improved productivity, reduced cycle time, better matching our customer needs, which may lead to increased market share. But also importantly, Six Sigma is allowing us to bring a culture change in our organization, focusing on continuous improvement of quality using facts in a structured system with measurable data. In this lecture, again, we want to introduce the 8 disciplines, or D, which is a problem-solving methodology using many of the tools from Six Sigma, but is focused on identifying, correcting, and preventing a problem. The 8 Ds are not part of Six Sigma, but they do help in many practical situations to structure a problem-solving process and to follow it through to the problem resolution. Now, the 8 Ds have their origins in the United States military and also in the automotive industry. Ford documented the 8D method in the late 1980s. And the method defines 8 disciplines or stages, and actually there's a new stage added, stage 0, so really 9 stages. And it's often used for handling customer complaints and reoccurring process problems. So, we're going to go through the 8 disciplines, and just note you will see slightly different versions in terminology. For this lecture, we're using the terminology given by Elmar Fedro in our guest lecture on his lecture in deviation management. But first, we're adding the zeroth discipline is when you become aware of the problem, when you prepare and plan for the 8D. Once it happens, you grab a team. Then you need to understand the problem and take containment actions. You need to find the root cause and choose a corrective action, implement the corrective action, and then learn and define prevention for the future before you release and congratulate the team. Now let's just have a quick review of the idea of what is a problem. Now, we looked earlier at control charts, which were proposed by Dr. Shewhart, and he talked about 2 different sources of variability in a process, either common causes or special causes. So, common causes are the aggregate of small, unavoidable variability arising from natural differences in, for example, the material used, the machines, the instruments, the environment. And this type of variability should be expected. Assignable causes or special causes are causes of variability arising from a specific occurrence, for example, a mistake or a broken machine. Now, common cause variability is an integral part of the process. It cannot be eliminated without investing resources. For example, Six Sigma, looking at where we are with our natural variability and then reducing that variability. Common causes must be accepted as part of the process. Special cause variability, on the other hand, produces disturbances in the process and usually increases the variability beyond acceptable levels. And this must be then discovered and eliminated. So we learn to look for these special causes using a control chart. We would take a sample of a stable process and we would calculate some kind of statistic. And we would look particularly at X bar and at R. From this sample statistic, we would construct 3 sigma control limits for that sample statistic. Again, so the sigma here is for the sample statistic, for example, the X bar. And then we would plot data from our samples, generally with time, and if something fell out of the control limits, we understood that we had a special cause. We understood that we had a variability that was due to something that is unexpected. In between these limits, we would see variation due to common cause variability. So as we just said, common cause variability, we would work on improving that with the Six Sigma methodology, going through the DMAIC cycle. But something that is out of control, a problem, we can use the 8D problem-solving methodology, which we then apply to bring long-term stability to our process. Once we're there, the Six Sigma allows us to improve our process capability. So let's go to our well-known process capability chart here. Now, I don't want to mix up the idea of taking samples and plotting a sample statistic on a control chart to identify special causes. Here we've got a critical to quality parameter. We're not looking at a sample statistic. And we know that anything that falls out of the specifications, the LSL and the USL, causes a defect. Anything outside of the specifications is a defect. Now, often, if we see a special cause in the control chart in our sample statistic, we could have a defect. We could mean that since we've moved out of control, we've also will see out of specification on the individual parts for that variable. I'm deliberately not drawing a control limit on this chart, but the idea is that the control limits would be spaced close enough so that if you're in control, you will not be out of spec. A stable, in-control process should be producing parts that are well within spec, meeting a high process capability. So how does this relate to AD? Well, again, with some sort of overlap possibly, the 8D helps bring stability to our process. We're removing those outliers due to special causes, and the Six Sigma then allows us to improve capability and shrink the overall sigma of our process. Okay, then let's go through the different steps of the 8D problem-solving methodology.